and welcome to Physical Geography 100 lecture podcast series. I'm Brian Krause, your instructor, and today we're going to be discussing transform boundaries in hotspots. In this mini lecture, like all mini lectures, I'm not going to cover all topics or ideas presented in the text. Rather, my aim is to highlight a few key ideas and discuss them in a bit more detail. So on that note, let's jump into the lecture. At the end of this lecture podcast, you should be able to describe a transform boundary and how it differs from other plate boundaries, describe the geological features of a transform boundary, and describe a hotspot and the volcanic formation associated with the hotspot. So the most prominent transform boundary on Earth is here in the United States, and it's in California, and it's called the San Andreas Fault. So a transform plate boundary means that the two plates slide side by side next to each other in the opposite direction. The San Andreas Fault is going to be the boundary between the North American plate traveling south and the Pacific plate traveling. The geological features associated with transform boundaries, you tend to get extremely strong earthquakes because there's a tremendous friction between the two plates grinding against each other, traveling in these opposite directions. So here's an illustration of a transform boundary where the convection cells are going to cause one plate to move north and the other south in the case of the San Andreas Fault. Here's a photograph of the San Andreas Fault with the big crack in the middle, with the North American plate on one side and with the Pacific plate on the other. So here we can see that the San Andreas Fault is the most prominent transform plate boundary, but it's not the only one. You have a small one called the Southwest Indian Ridge here as well. So this leads us to hotspots, and hotspots are an interesting phenomenon because you tend to get volcanoes in the middle of a plate compared to a plate boundary as we've seen before. So a plate is going to move over a magma pocket or a mantle plume under the surface. The magma is going to be forced up in the form of a volcano, and there tend to be very active volcanoes over a magma pocket. What happens is the plate moves and the volcano moves with it, so that volcano becomes inactive as the plate moves off the magma pocket. What happens here is that a new volcano forms behind the inactive one. This happens over and over and over, and you get a string of volcanoes with the active one over the magma. So some of the geological features associated with hotspots is you get very strong earthquakes because of the amount of magma that is traveling up to the surface. And you also tend to get these spectacular lava flows as well. Here's an example of the Hawaiian Hot Spot. Notice that Hawaii is the oldest island at 3.8 to 5.6 million years old, as it was the first to move over the magma pocket or the mantle plume, and is now the furthest away. Currently, Hawaii Island is the youngest and is still being created, since it is still over this hot spot. So from looking at the age of these islands, we can tell that the Pacific plate is moving in the north or northwest direction. So the only island that has any active volcano on it is Hawaii, because it is the only one that is still over this mantle plume. Now, Hawaii is not the only hotspot. There are a few others. There's the Yellowstone hotspot, the Galapagos Island hotspot, the Iceland hotspot, and the Canary Island hotspot. Notice that these hotspots are found away from plate boundaries, so it is the mantle plume or magma pocket that is creating these. So on that note, have a great day,